Alright, Assalamu alaikum guys. Let me start with another question regarding gravitation. That is October November 16 P43 question 1. This. Alright, let's move on. What the examiner says, a satellite is in a circular orbit of radius r about the earth of mass m as illustrated in figure 1.1. Alright, this is the figure 1.1. We have earth and the distance from the center of the earth to the satellite is r. That might be called, it might be what it is actually called a radius of orbit. All right, this is actually called radius of orbit. Now the examiner says the mass of the earth may be assumed to be concentrated at its center. All right, now let's move on. All right, now what we have here, the examiner says, the examiner focuses on something else. So this is actually this. All right, so what does it say now? In part A, show that the period t of the orbit period t of the orbit by the is given by the expression t equals to 4 pi square, that is t equals to 4 pi square in times r cube upon gm, where g is the gravitational constant. So how will we do it? Just see, explain your working, and you have done this in derivation too. So we actually know, अगर कोई भी चीज़ अगर circular orbit में होती है तो actually the force of attraction provides that circular orbit. Alright, so what will we do? We'll actually do it like this, that Fg, the gravitational pull, as in the question, the gravitational pull is equivalent to Fc, that is the gravitational attraction becomes equal to Fc. Alright, now what will we do? That is G m, that is mass of the satellite, small m, that is the radius is r square, and Fc turns out to be what? Mr, let's say omega square. Alright, this is the centripetal force because we have to use T2, we have to show T2, that's why I'm using Mr omega square in place of Fc. Alright, so this will turn out to be what? M will cancel out on both sides, that is the mass of the satellite as stated in the question, and I will be left with gm over r cube on this side, and this will be omega square. Now simplifying it further, I will actually write gm upon r cube, that is whole square of 2 pi upon t whole square. Alright, any issues? Alright, now moving forward, I'll actually use now I'll rearrange, that is I will be left with t square 4 pi square, because the square will also be on 2 and will also be on pi. Alright, and gm will be down and times r cube, hence it is shown. Alright, it is shown. Alright, let's move on to the next part, that is b1. What does the examiner says? A satellite in geostationary orbit appears to remain above the same point on the Earth and has a period of 24 hours. What will we do? State two other features of geostationary orbits. Alright, we have three features of geostationary orbit. One is it has a period of orbit, that is, it completes one orbit in 24 hours. That is same as the Earth. Alright, now the second आपके पास जो प्रॉपर्टी है, which a feature of a geostationary orbit is it is being launched over the equator, yani, which means it actually hovers over or has an orbit, equatorial orbit. All right, and the third feature is that it third feature is that only fixed number of geostationary orbits can be launched, geostationary satellites can be launched. All right, so let's move on. I'll actually write three other features. It must have an equatorial orbit, and and the second feature that I'm writing, that it must be rotating from west to east. Sorry, I didn't say it before, but right now I just I just actually remembered it and I just said it. Alright, I'm writing the other two features. One is it must revolve or rotate from west to east, that is the same direction of rotation of earth, because it needs to be geostationary. All right, the second feature is that it should have an equatorial orbit. It should have an equatorial orbit or must be launched over the equator. Right, must be launched over the equator. All right. Now moving on. That is the last part of this question. All right. No, this is not the past. That's why let's move on to part B2. All right. Now we have, what do we have here? We have something. The examiner says the mass m of the Earth is 6.0 10 to the power 24 kgs. Use the expression in A to determine the radius of geostationary orbit. How will we determine the radius? We have to use this expression that is given over here, that is t square equals to 4 pi square times r cube upon gm. So what will we use? We'll actually use this expression, that is t square equals 4 pi square, that is r cube upon gm. Alright, now what will we do? We have to determine the radius, so we'll actually first simplify. That will be t square times gm divided by 4 pi square. Alright, this will be it. Now I'll substitute the values. What will be the value of t? We know that for a geostationary orbit, the satellite must have a period of orbit of 24 hours. That is stated in question B12. So actually we have to state it in seconds. So I will actually write that is 24 hours into multiply by 3600 per square equals to, or alright, q, alright, that will be what, that will be g, alright, this will be multiplied by g2. Alright, I just missed it. This will be 6.67 10 to the power minus 11, and the mass of the Earth will also be multiplied, that is 6.0 into 10 to the power 24, that is in kgs. This whole divided by actually 4 pi square, and this whole I will have a cube root on it. I will have a cube root on it because this will be equals to r. Alright, now I'll be finding the value of radius, that is the orbit. Alright, let me bring the calculator in. Alright, now what will we do? We'll actually use this fraction and substitute the values, that is 24 multiplied by 3600 whole square multiplied by 6.67 span minus 11 multiplied by 6.0. Let me have a look at it. Multiplied by span plus 24. Alright, that will be divided by 4 into pi square. Alright, now let me see the answer. What is the answer? That is 7.56 10 to the power 22, but we have to take the cube root of it. Answer. So that turns out to be what? 42.3. Alright, let me 42.3. Alright, let me do it like this. That is 4.2 10 to the power 7 meters, because I have to state it in meters. Alright, any issues in this part? I hope so. No. Alright guys, and now this is the part C of that question. Alright, in part C of that question, the examiner of this question, the examiner states a global positioning system GPS satellite orbits the Earth at a height of 2.0 10 to the power 4 kilometers above the Earth's surface. Now there is a GPS satellite, and that is orbiting above the Earth, and it has a height of 2.0 10 to the power 4 kilometers above the Earth's surface. You must note this. Alright, now the radius of the Earth is 6.4 10 to the power 3 kilometers. Alright, you know this. Use your answer in B2 and the expression t square proportional to r cube. Now this expression is actually here. It actually is being derived or is said to be the Kepler's law that applies in gravitation. Alright, how will we calculate in hours the period of orbit of the satellite? We have to calculate the period of orbit of the satellite. So simply what we'll do, if it's a mathematical relationship, and we know this, how to use this. हमें पता है that if two things are proportional to each other, what will we do? That we'll use t square proportional to r cube, and we can rewrite it in the form t square upon r cube 1, that is for the first quantity, and that will be equals to t square for the second quantity upon r cube for the second quantity. Alright, now we have it. So this is that thing. Right, now what will we do? We'll actually put in the values. We have a time period of orbit. We have a discussion of Earth. So we know that the period of orbit is 24 hours, and we have to calculate the answer in hours. So what will I do? We have to calculate the answer in hours. Alright. Now what will I do? I'll actually put it as it is. That is 24 hours for Earth, and the radius of orbit of the Earth we have just calculated it. That was actually 4.2 10 to the power 7 meters. Alright, and this will be squared and this will be cubed. Alright, and what will this be? The period of orbit will now be, because it has, this is the Earth, and this height is actually 2.0 10 to the power 4 kilometers. So we need to include the radius too. the, the satellite is here, the satellite is actually here, so we need to include the radius too. So the new Apkipos, the radius will be, that will be 6.4 10 to the power 3 plus, that will be whole bracket, plus 2.0 10 to the power 4. Alright, this will be multiplied by 1000, and this whole answer will be cubed. Alright, we know this. Now the for the time period we need to find it, that will be square. Alright, now let me do it on a calculator. This is something very tricky over here. So what will I do? I'll use my calculator, and let's say I'm actually putting these values. That is actually this. Alright, now is it visible? Yes, it's visible now. Now see, what will I do? That is, सबसे पहले 24 square divided by 4.2 span plus 7 whole cube. Oops, that is 3. So that is whole cube. Alright, and this whole thing above will be multiplied by something like this. That is, alright, now I'll use another bracket. That is 6.4, oops, 6.4 span. Wait, let me just calculate it. Let me keep it simple. Wait, let me just calculate it. Let me keep it simple. Right, the left part comes out to be 7.7 into 10 to the power minus 21. So I'll just write the left answer. That is 7.77 into 10 to the power minus 21. Alright, now we have t square over here, and I'll just simply add this over. So this will turn out to be what? This will be 6.4 plus 3. Alright, 6.4. Alright, 6.4 expand plus 3 plus 2.0 expand plus 4, and this we multiply by 1000. So this will be 2.64 10 to the power 7. Alright, now this will be 2.64 into 10 to the power 7, and this will be cubed. Alright, what will I do now? I'll just simply multiply. I'll take the cube of it. Answer cube multiply by my previous answer. That was actually 7.77 and minus 21. Alright, now we'll take the root of the answer. Now time period turns out to be, that is 11.95. Alright, now the time period turns out 11.95. So what will I write? Actually, I'll actually write the answer. That is, time period turns out to be 11.95. That is approximately equals to 12 hours. So I'll actually write 12 hours away. Alright, see you in the next question.